Hi everyone, welcome to Data Science using Pandas tutorial series. We are now reached a video which is going to be very important because we are going to understand how do I handle missing data. So this video will be divided into two parts. So first part is what this current video is going to focus. So let's get going. So in this video we are trying to understand the missing data first of all. Then how do I basically handle the missing data? The reason for handling the missing data is because whenever you have a temperature information for years together, or say for example stock data information for years together, or for that matter other data which is voluminous in nature, in that case you are bound to have a situation where the data is missing or it's not available completely like that. So in that case you have to have an approach where you deal with those particular missing data so that you are able to do the data analytics. So fill approaches plays a very important role in that. And then after that we are going to understand a technique called as interpolation, which is one of the techniques that is used as part of dealing with the missing data and the fill approaches. So as part of this presentation, basically we need to understand to handle a missing data in a CSV file, because we already have seen how to deal with a CSV file. So if I get a CSV file and it has the missing data, then what can be the actions that can be taken? So the first action itself could be you create an index with a particular column as an index. So for example, if you have a time series data and it is like a date, so for a particular date this is the data, then another date 2, this is the data, like that. So it can be a stock market data, or it can be a temperature data or a weather data, like that. And in that case you basically are going to create an index. Then whenever there is a nan or not a number, then you can replace those values with the 0. So this is one of the approach that people use. Then instead of that you can control it in a better way. We have seen it in previous video where we can make use of a dictionary, and then you can control the behavior at the column level. Apart from that, then the little advanced techniques are you can make use of a forward filling. You will see this in detail or in practice. Then similarly we can have a backward filling or backward fill. Then you can have an approach where you do the interpolation. Then you can do some cleaning of that. Then you can have a sort of a time series. Suppose if it is a date time series, then you can insert the missing dates also. So we will see this in action. Then at times you can do re-indexing, because if you are going to insert something in between, then obviously your index changes, so you need to do the re-indexing. So let's now go to program, and we will try to see that in working in the Jupyter. When it comes to interpolation, we will try to understand the various functions that are available, and then once again we will go to the Jupyter. So let's now go to Jupyter. So here we have basically imported the pandas. So let's run that. So we have imported the pandas, and then we have created a sort of a data, and now this data is taken from the big data, that is, or the large data that was shown as part of the previous videos. So on that we have taken a very small piece of data and sort of we have created it, I would say. The reason is because we want to basically understand those techniques like interpolation, forward filling, backward filling and all that. So for that you require a data which is relatively small in size, so that you understand how these things are working. So this is that Excel file where we have created the data, and it has very few columns only. So date, then the temperature, wind speed, and then the event. So these are the only 4 columns that are available or that we have purposefully handmade it. We are now going to read this file. So once I read it, and then if I print it, then I am going to get this data. There is nothing great about it. However, now there is an index that is created. So I am not interested in getting such a data, because I can't do anything, because for me the date happens to be an important column, because for that particular date there is a temperature data, there is a wind speed data, and then there is an event information. So basically I want to make use of a read CSV function only, where it can deal with date as a property. So here we are going to make use of parse underscore dates as the one option, which is part of read CSV, and we are going to make use of it so that it is going to treat this date column as a date and not just as a string. So now if I just do it, then in that case now you can see it has changed it. So it has now it is considered it as a date. So here now we have parsed the date column as a date type. So if I just try to print the type of this particular thing, date, then in that case you can see that it is now clearly coming as it as a date. So I can always use df.date or df in rectangular bracket date. So either of that is okay. So here what we have done is we have converted it to the date type. That means it's now becomes a time stamp. Now I can, if I just want to confirm it, I can just say type. So you can see it becomes of the type timestamps dot timestamp. So that is what we are interested in, which was not the case if I didn't use parse underscore date. So parse underscore date happens to be very important feature of this read CSV function. So now we can set the index, because now I am not interested in the sort of a dummy index where was 0, 1, 2, 3, but I will make date as my index and then I change it to in place is equal to true. So then in that case my df changes and now I don't see 0, 1, 2, 3. However, my date now comes in bold, and then so for this particular date, this is a temperature, wind speed, event, like that. Now you see it in a very clear understanding happens instead of having a dummy index. So date now is my index. So once I get it, so it's like a first level of processing I have done by indexing date, by rather using date as an index. Now I want to, there are now in this there are nan, that means not a number. So here you can see there is nothing available. So here some of these things are empty, like there is no event information. Then wind speed is not available here, like that. Then now this is completely empty here for 8th of January and 9th of January, like that. So if this is the case, then what should I do? So I need to deal with such type of situation. So what I do is I basically replace all the nan with say 0. So this is a very simple technique. So if I now just do it and create a new data frame, so what is now happening is, when there are cases where there was a event which was a nan, this was a nan, this was a nan. Now wherever there was a nan, that also got, that basically became 0. Now this becomes little odd when I have a event called 0, Okay, this is still okay, like I have a temperature 0 degree, wind speed also can be 0, but close to 0, obviously it cannot be 0, but close to 0. But this is little awkward, like you have an event which is 0, that means you need to have a better way of handling nan rather than making it 0. So then you basically make use of a dictionary and then you control it as like a column wise. So then you make use of 0 for only temperature and wind speed, and whenever there is an event information which is a nan or not available, then in that case you make it as like, you write it like a no event. So use this dictionary and then you fill that. So using this, so you are using the function called as fill na. So fill na is again used instead of 0. Now you provide with a custom dictionary. So here you are providing with your custom dictionary, and fill na means fill not available value. So now let's run this. So when I run this, so you can see now here no event has come, and similarly here no event has come instead of 0. So now this is at least better, somewhat better than basically just making it 0. Now we can replace that. So we can now use the technique which I just told you, like forward filling. So this is the do forward filling and do backward filling. So these are the techniques that we want to make use of that. So we will use the ffill function. In the previous one we have just used fill na. Now I want to make use of ffill. So f stands for forward and then fill. And here what does it do? It is basically going to replace temperature and wherever it's not available with a better estimate, which is called as forward filling. So it carries forward the previous data. That means the previous, because now previous data is at least nearer to reality or the truth than just putting it 0. So for example, on the 1st of January the temperature was 38 for the approximate temperature for whole day was 38. Now you make it 0. Now this is very awkward. So if you just say 38, then at least it is closer. Probably the temperature could have been 40, could have been say 35. So at least 35 or 38 is nearer to 40 or say 35 rather than just simply making it 0. So that is where the forward fill comes into picture. So we will make use of this forward fill and the method, or you can still use the function fill NA and then you specify the type of method or the method that you want to use. So we will just do that. So ffill we are using, so df.ffill. So now you can see 38 got copied here. Then similarly here there was 0, so on 5th. So this 6 got copied here in the wind speed. Like that you can say it is a forward filling. That means it has taken one step ahead and it has copied the previous data. Now I can, how many times it needs to copy? The problem here is because now here there could be a case where there are say 2 zeros, or here there is 2 empties are there. So for example here 37, and after 37 2 were 0. So here these are the 2 zeros are there. So if I just use forward fill, then what is happening? It has copied till it didn't find any value. So you can limit it. So how long you should basically forward it, or you forward copy it, or forward take it forward in the forward direction. So you can use limit is equal to 1. So by doing limit is equal to 1, you are restricting its forward fill or approach forward. So now you can see this 37 got copied only once, however this remains 9. Similarly here it has happened like that. So the point here is now you are controlling to what extent you would like copy in the forward direction. So if you say limit is equal to 1, so it is going to limit to only one cell. Similarly I can have a backward filling. So I can do backward filling, and then again I can use limit if I want it. So here I am now going to do reverse. So that means wherever there is no data available, say for example 34 would have got copied on, so 10th of January data would have got copied to now 9th of January. So that is like a backward filling. So here you can see, so here when I run this backward filling, you can see this 10th of Jan was copied into the 9th of January. So 34 was copied. Similarly here you can see in the other places. So this is called as backward fill. If I want to limit again, if there is a case where it is more than one empty and you want to limit it to only one, then you can use limit is equal to 1, and the method is bfill. So if you make use of function fill NA, then you need to specify method, or you can directly make use of the function bfill. So there are two functions, one is ffill and another is bfill. So for ffill is for forward fill and bfill is for the backward fill, or a generalized function as fill NA, and then you specify the method and the limit. Okay, so these are the two techniques. Then comes the so we can just simply do fill NA across axis also. So you can do it across axis. So here you can see now this was the case where 52 got copied everywhere. So let's take a look at the original data. So original data was this one. So here you can see 52. So 52, this was 0 and there was no event. So this 52 got copied everywhere. So here now you can see 52 got copied when I use this another approach which is called as fill NA, and here I am using method is a bfill, but now I have given an axis column. That means it is going to do column wise copy. So this again depends whether you really want to make use of this approach, but it can do that way. So 52, 52. So again this copy is not a correct one. Why? Because wind speed became 52. So again it is very off from the approximate value. Then 52 even doesn't mean anything. So again this technique has to be used if you really want, or you know what exactly you are doing. So this is like copying value horizontally with axis is equal to column. Similarly, you can do copying value horizontally by using method bfill, that means backward filling, and then with respect to column. So again you can play with it and it can copy like that. So here you can see that particular thing is copied in a column wise. So this is about the horizontal copying, that means copying values horizontally with axis or across the axis. Then we have another interesting method called as interpolation. So what does interpolation do? Let's take a look at it. So interpolation is basically used to do the interpolation, like you basically are now going to interpolate, like you have some data and you are using a technique. So the technique can be a linear interpolation, cubic interpolation, like that. So many times people use linear interpolation and then they play with it, whether which is going with the values that I am looking for, or which is closer to the truth. So that is, so here the method you are going to make use of it is interpolate, and the method is here, the function is interpolate and the method is linear. and then across axis is equal to 0, and then in place can be true or false, depends on that. So linear is one where you ignore the index and treat the values as equally spaced. This is the only method supported on multi-indexing. So suppose if you are going to do multi-indexing, then linear is the one. Apart from that, then there is a time, so which works on the daily and high resolution data, because we will use this because we have date as a time. So whenever there is a time column is there and you want to interpolate it across time, then you can with respect to time, then you can use this time feature also. Then there are other things like quadratic, cubic, spline and all that, so you can play with all these other approaches which are available as part of this particular method, which is df.interpolate. So let's now go to the Jupyter. So now we will make use of this linear interpolation. So by default it is linear interpolation. So using interpolation for better estimating, because what we have done is up to now we were using backward fill or forward fill, or say filling across column. So that is, these are primitive techniques. So better technique is, why don't you use a sort of a better approach called as interpolation. So if I do it interpolation, then there is some mathematical thing that has been taken care, and now it is going to interpolate. So here now you can see this new df is now df.interpolate. So if I just try to print df, so let me just try to print df here. If I just say df, you can see this was the df 38, then nan, then wind speed nan, like that. So this was my data. Now by using linear interpolation, what it has done, it has come up with a better one. So probably it would have taken an average, so or something closer to that. So here now you can see this has become 45, because this was 52. So this now, instead of copying 38, earlier we did try to copy 38, or say backward fill would have copied 52 here. Instead of that, it came with an interpolated value. So this is 45. Similarly here you can see this 6 and 9. So probably in between it came with 7.5. So like that you can do the interpolation. So this is like a linear interpolation. Obviously it's not going to work on the text, it's going to work on numbers. So 9 as in the event, it has just kept 9 as 9. Then you can use method time. So interpolation method time. So here you can see in between things it has introduced. So here 1, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here it has used the time. So instead of 45, now the value that has come here is 48. Why? Because it has now calculated, okay, this is 1st of January, this is 4th of January, so 4th is nearer to 5th. However, there is a difference between 1 and 4, so probably instead of just taking like the average which did it probably in the earlier technique like 45, it came up with a better estimate like 48.5. So like that the time approach also works. So this is a very powerful feature when it comes to interpolation with respect to time. Then you can drop all the columns or all the rows which has at least one nan. That means you can't use that data, so you can drop it. So whenever there is a one nan, so it can drop. So you can specify how, that is how is equal to all, so that is another way, or you can simply say df.drop na. So automatically at least one nan, whenever there is a row which is having at least one nan, will be dropped. You can specify threshold, because if you do not want rows with only one nan to be dropped, so if you want it that, let's say there is more than one, then in that case you can use a threshold, and you can see that it will drop only when there are more than one nan is available. So threshold is 1. So like that you can get the data. Then you can use threshold is equal to 2, then you can still see a better, or you can, this is your decision which rows you want to drop depending on the threshold. So if there are two valid names, so drop rows which are less than 2 valid values. Then you can do reindexing. So as I told you, you can do the reindexing. So now this is a date range from 1st of January to say 12th of December of 2005. So this is that. So you can basically, so this is like a date range. This is that pd.date range, and I am creating a dt frame. So I want to insert it. So now I then basically created an index, pd.datetime index, and then df. So this is the new df, in that I am just doing the reindexing with the index. So whatever the index I just have created, I am doing it on my previous data. So if I do it, now you can see in between data also got inserted. So 2nd, then 3rd of January, then like that till 12th of January it has inserted. Sorry, it is not December, it is 12th of January. So from 1st till 12th it has basically created. So earlier data was not, there was a missing date in between. So let's say 2, 3 was missing, here 5 was missing, then probably 9 was missing, like that. So now you can see here 2, 3 got inserted, and however it has inserted it 9. That means you can do re-indexing and you can insert the missing dates also. So this is what we basically have seen as part of the handling the missing data. I hope you like this video. So in this video basically we have seen the fill approaches. So that means we have seen, just to summarize, we have basically replaced NaN values with zeros, then we made use of a better approach, that means using dictionary. Then we understood forward fill, backward fill. Then we have made use of forward and back filling with respect to axis. Then we have seen interpolation, linear interpolation. Then we have seen time series interpolation. Then we cleaned the data, then we inserted the missing data, and then we have done the re-indexing. So I hope you like this video, and in the next video we are going to cover the much more little advanced things like regex and all that as part of the next video. Thank you.